form of a cubic. Okay, so again, linear, the exponent's 1. Quadratic, the exponent's 2. Cubic, the exponent's 3. We just have that x. Okay, absolute value, the x is inside the absolute value. Okay, now we're going to be doing 3 things to these graphs, and we're going to be looking at how would you make this graph move up? How would you make this graph move to the right? What would you do to the parent function to make it move? Okay, is that crazy?
No.
Oh, all right.
Sure.
So let's go back to linear. Right, there's my most parent, it's my parent function, y equals x. Everybody knows f of x means y, right? Everybody okay with that? F of x is the same thing as y. Okay, so any idea what I could do to make this graph move up? Any idea? How do you make a graph go up? Change the y? How would I change the y? What would I do to change the y? Like, would I add a number here, multiply by a number here, divide by a number here? What would I do to make it move up? So I'm here and then add a number. Should I try it? Okay. So I am going to add a number. Did that work? So you see now it says x plus 1. Did it move? Let's try it again. Ready? I'm going to add 1. Did it move?
Yeah.
Add 2. How much did it move by adding? So I added 2 and you're saying it moved up 2?
Yeah.
Is that what's happening? Is that all that's happening? It just moved up, it didn't change any other way? Watch it move. Is it changing any other way? Is it getting steeper? No? Okay. If I take away, it's going down, right? So what do you think? Is that going to be true for a parabola? Let's make this a parabola. So you're saying if I add 1, it's going to move it up 1. Watch the red dot. You ready? I'm going to add 1. Does it move it up 1? Did everything else stay the same? Let's try it again. Ready? Here we are. Look at it. Everybody staring at the parabola?
Yeah.
Okay, watch the parabola and the red dot. I'm going to add 1. Did anything else change? No? Let's add 2. Did anything else change? No? Add 3. Did anything else change? It just moved up that much, right? Okay, let's check out a cubic function. Here we go. There's that cubic function. Ready? I'm going to add 1. Watch it. Did anything else change but moving up 1? Add another 1. Did anything else change? What about subtracting? What if I want to move it down? So I subtract 1. Did it move down? Put it back. Ready? I'm going to put a -1, so I subtract 1. Did it move down? Are you guys watching? Because you're all staring at me like this is a tough question. This is a pretty easy question, right? Let's watch it again. Ready? We're watching this. Okay, I am going to subtract 1, and you're watching to see, did it move down 1, and did it change any other way? Okay, so, did it change any other way? Did it change any other way? No? So, are we all, maybe this just seems too simple, and you're like, maybe I'm not getting it because it seems too simple. I'm just saying, how can I make a graph go up or down? What would you tell me? Add or subtract 1 to the end, right? Add or subtract 1 to the end. Do we get that? Because I'm going to be giving you all kinds of problems here soon that go through that and ask you that. But we've got other things we can do. Let me get rid of this. Okay, what do you think would happen if I was to multiply by something? Let's go back to having linear. You know, if I multiply by it, what am I doing? What am I putting in there? If I put a number in front of x other than 1, if I put a 2 there, what happens? The slope changes. And how does the slope change? If I put a 2 here, what happened to the slope? It got steeper, right? Everybody agree? It got steeper. Okay, let me make this a parabola. Okay, what if I put a number in front of the parabola? What's going to happen? skinnier? Can we relate that to slope at all? If I put a number there, does it get steeper? Just like the slope made it get steeper? Do you remember when we talked about problems? We stretched it up when we had that a value there, right? We made it stretch up. Do you think that's going to be the same if we had a cubic? Okay, watch it. I'm going to put a 2 in front of the x cubed. What are you going to predict is going to happen? What are we predicting? Steeper? So you're expecting to go up like this, right? Which means it does get skinnier, but you're expecting to go up. Watch it. Are you all watching the graph? Ready? Here we go. Did it get steeper? Is it getting steeper? Okay. Now, what's the moral of the story for this? The number in front, when you multiply by a number in front, it'll make it steeper the bigger the number is, right? The bigger the number is, the more stretched out, the more steep it gets. Okay, what if I made the number negative? What if I made it negative?
Flatter.
Okay, ready? What's the opposite?
Flatter.
Not less steep.
Well, if I made this 1/2, then it would be not steep, right?
Not less steep. Wouldn't be like not steep.
Not as steep is what I said.
Yeah, no, that's not. I was saying what Chris said.
Oh, I wasn't listening to Chris. Okay, if I made this number 1/2, it would make it less steep, right? If I made it 1/4, it'd make it less steep. I'm asking though, what if I made it negative?
When you just inverse it,
So what do you mean by inverse it?
like the sides where it would switch basically, like the side that's going up, that would go down.
What do you think?
I think David's a genius.
David's a genius. We've all established. Ready? Let's check it out. So I'm going to, it's going to go to 0 first, so it's going to like flatline, but then you'll see the negative. Are you ready? Here we go. Was he right?
He was definitely.
Okay. All right, let's do this now, a parabola. So if I make it a negative in front of the parabola, in front of the x squared, if I make it a negative, what are you expecting to happen? Open down, let's check it out. Okay. What about a line? If I made it negative, I mean, this should be a silly question because we know so much about lines. We worked on it so hard, right? So if I made it a -1 in front of the x, what are we expecting to happen? Negative slope does what? Goes down. Right? Okay. So what have we learned so far? What happens if I add or subtract at the end? Moves up or down. What if I multiply in front by a big positive number? How does it change it? Steeper. What if I made it a negative number? Flips it over, right? It'll flip it over if it was positive. Now it's negative. Okay? And then the bigger that number, the steeper it is. So we've talked about 2 things that can happen. There's one more thing that we need to look at. Unfortunately, this doesn't do it. Okay? Now what we're going to look at is, what if oh, we haven't talked about that here, by the way. So if I add a number here, it's going to move it up or down, right?
Yeah.
Okay? If I take and I multiply by a number here, it's going to change how steep it is, right?
Yeah.
Okay, same thing, same idea. And so this is what we haven't done in our class, is we haven't talked about this in terms of just in general. If I do this in general, we've talked about it with lines. We've talked about it with quadratics, right? Because plus c is our y-intercept, but really technically it's just moving it up or down, okay? So that's why we're doing this, is we're talking about in general, and we can do this to any equation and this would happen. The one thing we haven't done is, what if, instead of adding or subtracting at the end, what if I took and I added inside? Do you know what I'm saying, inside? Right? If I added inside here, what would happen? Linear is kind of silly to talk about that, but what would happen if I added inside? Or if I subtracted inside the function? Do you guys understand what I mean by inside the function, right? I'm not just putting it on the end. I'm not just saying x squared plus 2. I'm saying the plus 2 is inside the squared. And the plus 2 is inside the cubed. And the plus 2 is inside the absolute value. Not outside at the end. but inside whatever math is going on there, what's going to happen, okay? Can you get out your graphing calculator for me, and I want you to mirror it up here? I know. Anybody have an idea what's going to happen if I add inside?
It's gonna not move on an axis.
Huh?
I don't know.
Move left and right.
Left and right? What makes you say that? Because you already knew that.
'Cause it-
What haven't we done? Right? We made it get taller and shorter. We've moved it up and down. What haven't we done? Left and right, right?
What's your name?
We haven't moved it. Getting tricky.
Getting tree? Wow,
Yep.
that's weird.
I know. I was told to come up with something clever, and that's all I had. Okay, so here we go. Here's what I'm going to do. I'm going to put x squared. Okay, so that's going to be the red one, and then I'm going to do x plus 2 squared, and that'll be the blue one. Do you see the difference here? Okay, so I have x squared. And then I put inside the bubble, I put x plus 2, and then I squared that. So we're saying it's going to either move it left or right. That's our prediction, right? Does anybody want to predict more specifically? Do you think it'll move it right, or do you think it'll move it left? And how much?
Move it right.
Right.
You're going to move it right 2,
Mm-hmm.
because it's positive, is what you're saying. And it's 2. All right, let's check it out. What the heck?
Gotta zoom out.
Why did I pick you? What am I doing?
You're zooming out, you gotta zoom in.
Oh my goodness. I'm being videotaped on this too. And why is there a purple one, Hunter?
Because you didn't delete all of them.
Well,
That's why it's strong.
Mhm.
And you should know how to use your own. Oh, I moved it left. What a
What?
turd.
let me get rid of that purple one. That's annoying.
I like it.
Well, that's just too bad. You keep it on yours. Okay, wait now. You guys said to the right too, didn't you?
No, we didn't. We said left.
Okay, so we have x squared. That's this red one. That's the parent. Remember, the parent one always kind of starts at the origin and just goes simply from there. Okay, and then we had x plus 2 in the bubble, and it moved it the exact same thing, but it moved it to the left, didn't it? So how would I get it to move to the right?
Negative.
What should I put? If I wanted to move to the right, I should do x
Minus 2.
minus 2. Let's check it out. So this one is say, so that's green.
It's probably not gonna work.
So did the green one move to the right too?
Yeah. I just figured that it was she's trying to trick us.
Now let's just compare that, you guys. Remember how I said about adding inside or outside? Right? Okay. So if here I have x plus 2 inside the parenthesis, what does it look like if I just added it outside? So x squared plus 2.
It's gonna go up too.
Do you guys see what I'm saying? I'm saying the x squared plus 2, so it's after the squared. Yeah, what is it going to do?
Up to.
Up 2. So you see how the green one's up 2? It's the same one, it's just up 2. But then if I did it inside the squared, it moved it to the left 2. So here's what's happening, you guys. When I do it inside the squared, I'm messing with just the x, right? I'm messing with the x there. And x goes this way, doesn't it? X goes this way. You with me? X goes this way. Okay? But when I add 2 to the end, I'm saying whatever I got here. Hey, do you remember what this is over here? What is this? What? Like here I have an x. What does this stand for?
Why?
The y.
Wow.
You listening? This stands for the y. So whatever I get here as an answer, I'm saying y equals that answer. So when I add 2 at the end, I'm changing the y value. I'm adding 2 to the y value, right? I'm adding 2 to the y value. And that's why it moves up, because this is the y-axis. Y-axis is up and down. But if I mess with the x value inside the bubble, if I mess with that x value, I'm now moving it left and right. But what's weird is it moves it the opposite way, right? We moved it to the left 2 instead of to the right 2. Okay? So that's the lesson on that. Those are the 3 things we changed. We move it up and down by adding to the end, or subtracting on the end. We move it left or right by adding or subtracting inside the function with the x. And then we change how steep it is by doing what? Multiplying. Okay. So we're actually going to now try some problems. You can go ahead and hit it.